Hello everyone, welcome back to the channel. Let me ask you a question. What do your washing machine, your smartwatch, your car, even your toothbrush all have in common? They all have a hidden brain inside them. Not a brain like yours or mine. Not even like the one inside your laptop. It's a tiny computer. A computer you probably never notice. A computer that doesn't complain, doesn't get virus, and doesn't update itself every week. A computer that quietly does one job day after day, year after year. Today, I'm going to show you what embedded systems are, why they matter, and how they control almost piece of technology around us. By the end of the video, you'll see the world differently. Trust me. Once you spot them, you realize they are everywhere. Let me tell you a quick story. You're driving on the highway. Suddenly the car in front of you slams the brake. You slam your brakes too, and in that instant, faster than you can blink, something amazing happened. A hidden computer inside your car, connected to wheel sensors, check how fast each wheel is turning. It realized one wheel is about to look up. The tire is about to skid. So what does it do? It instantly tells your braking system, halt this brake, release and apply again. Keep traction. This is your anti-lock braking system or ABS. It doesn't magic. It's an embedded system saving your life in real time. It's why embedded systems aren't just nerdy tech, they are critical. They are literally the difference between safety and disaster. So let's answer the big question. What is an embedded system? Here's the official textbook definition. An embedded system is a computer system with a dedicated function within a larger mechanical or electrical system. But let me say it simply. An embedded system is a computer with a job, not like your laptop which can open YouTube, editor and play game all at once, not like your phone which is loaded hundreds of apps. An embedded system is focused. It has one mission and execute that mission reliably, efficiently and often invisibly. It's like a stage crew in theater. You don't see them, but without them the show doesn't happen. It's move the prop, control the light, and make sure the performance run perfectly. That's exactly what embedded systems are. Hidden but essential. Think of it this way, a general purpose chef like the one in a fancy restaurant knows how to cook hundreds of dishes. It's flexible, but not be super fast at each one. An embedded chef, on the other hand, is a pizza master. He makes the same pizza all day, every day. It's always the same size, the same taste, even the same perfection. Your laptop is flexible chef, your washing machine is pizza master. One is versatile and other is specialized, and sometimes specialization is far more valuable. Every embedded system is made up of main three parts. Sensors, the eyes and ear, they collect information from the outside world like temperature, light, speed, sound, or pressure. For example, in your phone, the accelerometer senses the motion. In your smartwatch, sensor read your heart rate. In your car, sensor measure the wheel speed. Microcontroller, the brain. This is the smart chip that takes sensor data, run a program, and make decision. Think of it like a referee. It sees data, apply the rules, and decide what happens next. Actuators, the muscles. These perform the action, turning on a motor, opening a valve, lighting an LED, or beeping a buzzer. Altogether, the cycle is simple but powerful: sense, decide, and act. This loop repeats endlessly, sometimes thousands of times per second, and it's the heartbeat of every embedded system in the world. Let's go on a quick tour on your everyday life. Kitchen. The microwave, coffee machine, blender, and toaster all use embedded system to measure time, control heat, and beep at you when the job is down. Living room. Your TV remote, your game controller, your smart speaker all have tiny brain inside decoding signal and managing power. Healthcare. A pacemaker in a patient's chest is an embedded system. It measures heartbeat and delivers tiny electrical pulse to keep your heart beating. An insulin pump is an embedded system inject medicine at the right intervals. These are literally saving lives. Transportation. Cars are packed with embedded system. In fact, the modern car may contain more than 100 embedded systems. They run the engine, control airbag, manage the radio, adjust the seat, and even handle automatic parking. Daily gadgets, smartwatches, printers, calculators, washing machine, elevators, each has an embedded system quietly doing its job. And here's the crazy part. There is tens of billions of embedded systems in use today. That's more than the number of human, dogs, and cats combined. So yes, embedded systems outnumber us all. Now you might wonder, why not use a regular computer for everything? Why invent this special system? Because embedded systems have three superpowers. Specialization. They do one job and they do it perfectly, no wasted resources. Efficiency. They run on tiny memory, tiny processor, and very low power. Some can run for years on single battery. Reliability. They must work non-stop, often in safety critical situations. If your phone lags for a second, it's annoying. If an airbag lags for a second, it's deadly. That's why embedded system must be designed with reliability in mind. Let's zoom inside the microcontroller chip, the true heart of embedded system. CPU, execute instruction and the decision maker. Memory, flash for permanent program, RAM for temporary variables, and EEPROM for permanent settings. I/O pins, connect to sensors and actuators. Peripherals, like timer, ADCs, DACs, or communication interfaces like UART, SPI, or I2C. All of this fits into a chip smaller than your fingernail, and you can buy one for less than a cup of coffee. But it's not all perfect. Embedded systems come with very limitation. Power must super low, memory is tiny, and cost matter. Every cent counts in mass production. And timing is critical. They often need microsecond responses. This is why embedded system engineering must write super efficient and lean code, because every line matters and every cycle counts. So how the engineering create embedded systems? The process usually looks like this. 1. Define the requirements. 2. Choose the right microcontroller. 3. Design the circuit and PCB. 4. Write the firmware. 5. Test and debug in real condition. 6. Optimization for power, cost, and speed. 7. Deploy into a million of devices. It's a journey from an idea in someone's head to a physical product in your hands. Let me show you a simple example. Here's a knob and an LED. The program reads the knob, decide the brightness, and change the LED. Watch, when I turn the knob, the LED smokes fade up and down. This is the entire cycle of an embedded system life. Sense, decide, and act. Simple, powerful, but everywhere. So now you know. An embedded system is a tiny and specialized computer that senses the world, make decisions, and act reliably. They are in your home, your car, your gadgets, even life-saving medical devices. They may be invisible, but they are the backbone of modern technology. In the next video, you'll dive into the difference between microcontroller, microprocessor, and SoCs. You won't want to miss that. If you enjoyed this video, please like, subscribe, and share it for your friend. I'm Ali Reza, and I'm see you in the next one.